Warning: vacuum tube amplifiers have lethal voltages inside them, and checking their voltages can be extremely dangerous if you don't have the equipment or understand the safety protocols needed. Hey y'all! Well, today's the day we're going to be powering up the output tubes on this amp, which to me it's just the exciting part, because up till now we just had a bunch of passives we were soldering together, and this is where the amp really comes to life. So first I want to talk about some of the safety stuff. Obviously, we're working with high voltages, you need to be really careful. And so I have some of the safety gear I use. Here's my Variac, and it goes from 0 to 130 volts. So we can vary the voltage going into the amplifier. Then I have my isolation transformer. And then after that I have this 200 watt bulb that's wired in series. That's my dim bulb that is a current limiter in case we have a short or something else going on in the amplifier we don't know about. The other thing is, once you plug the power cord into this, you have to pretend like you only have one hand. This other hand doesn't leave your lap. So that's the main safety thing, is you do not want the voltage going across your heart. It doesn't mean you can be careless and start just poking around inside here, but the main reason people get killed doing this is they're holding onto something like this is grounded. These screws are connected to earth. Even with this isolation transformer, it doesn't mean you're perfectly safe. It just means if you really do something stupid, maybe you won't get electrocuted. So don't pretend on this to protect you. You got to use this to protect yourself. The other thing I want to talk about is like what we're anticipating today. And on this previous amp, we used a 710 volt power transformer, and this one has a 700 volt one. So we know we're going to have about 10 less volts going into the rectifier tube. The previous amp I used a 5V4G, which has a little more voltage drop than this 5AR4 or GZ34 rectifier tube has. What we're hoping this time is to get a very similar voltage that I got out of the other setup using this much more readily available tube. While we're talking about 5AR4s, do not use a JJ 5AR4. They do not work when you have the voltages this high. They may work fine at a 250 volt guitar amp or something, but when you get the voltages up over 400, they spark out. I've had a couple of them blow up. I quit using them. These Gold Lions work good. The Tube Amp Doctor TAD ones are another inexpensive option that work really well. Obviously the new old stock ones are good. These are the kind of tubes that basically last forever, and so there's not a lot of wear and tear on them like there are on output tubes, and most of them aren't running anywhere near what they're capable of conducting, and so the new old stock ones seem to work really good. So anyway, those are just some options on rectifier tubes. We may end up going with another rectifier tube if our B+ or our plate voltage gets too high and we're pulling too many watts through the output tubes, but we'll find out here shortly. While we're talking about that too, I've had some questions about, is this a true Class A amplifier? Well, a single-ended amplifier has to be a Class A, just the way it's made. It can't operate in any other class. And I feel like the reason it's called single-ended is the power goes in one end of the transformer and it comes out the other on the output transformer. So there's only like one end that the signal's going through. The second thing to understand about the two different kind of amplifiers is the other one that's a push-pull, the voltage goes in the center and then the power comes out both ends and goes to two different output tubes. And the way they're designed is that the signal comes in, it gets amplified by one of the driver tubes or the voltage amplifier, and then it goes to a splitter. And what the splitter does is it takes the positive part of the signal and sends it to one output tube, and then it takes the negative part and sends it to another. And then so each tube's doing less work. They get combined back together in the output transformer, and there's your complete signal again. Now, there's where the one problem is with a push-pull amp is when it's combining them back together, you can get some distortion there. And that's not an issue that a single-ended amp has. The other thing is, and I'll try to explain this as simply as I can with an analogy, because analogies help me kind of get things straight in my brain. With a push-pull amp, the signal acts more like the effect of you pushing the gas pedal on a car. And we're not touching the brakes, we're just doing the gas pedal. And so the more volume you give it, it's like pushing the gas pedal on your car, and the engine, which is like the tubes, only makes as much power as you're asking it with the volume knob. And so the tubes are in cooler, especially at low volume levels, and the amp itself is capable of a lot more power than an SE amp is. Now an SE amp, think about the volume knob is like modulating the brake pedal, overriding the engine. And we've got the gas pedal on the floor the whole time. The amp's running wide open. And the volume knob or the signal is modulating the brakes to get the amplification and the volume that we're looking for. So with an SE amp, you need to set it up where it's running the tube like really close to its maximum dissipation at idle, so that you have all that power there when you need it. If you run the tube really soft, you're giving up a lot of power, and I found the tubes just don't sound good. So I try to set them up running fairly high voltage and also running them as hot as I feel like I can get it, and the tubes still have some longevity. On this amp, these are $17 tubes. If these were $200 something 300B tubes, like I did on my 300B amp, we didn't run it nearly as hot as we're going to run these EL34s. So all that said, let's get busy checking voltages. First thing, hand in the lap. So one thing you have to be aware of is, because we're running tube rectification, we can't really expect much to happen if we just like dial in like 20 volts. It's just, you're just not going to get anywhere. So we're going to go ahead and set this on about 70 volts and then turn this on. Turn on make sure the probes are in the right holes. And we're going to come over here and start looking for some B+. Now, in another video, I will show you like where all the test points are. But for this one, I just kind of wanted to show you like how I'm doing the test things and some of the safety precautions. Oh. Might help if I turn the amp on. And nice thing about an indicator light, it tells you when you got power. Okay, back over here to our B+. And we're still not seeing anything. There we go. There's half a volt. And it's going to come up slower than it normally does because we're only putting a little over half the normal voltage into it. Okay. Good thing, keep an eye on the dim bulb when you turn it on. Nothing going on there, so that's a good sign. We know we don't have like a dead short inside the amplifier. If this thing ever glows like bright like a light bulb, turn everything off because you got a short somewhere. Okay, we got 230 volts. There's 232. Okay, and you probably can't see this, but this bulb is just starting to glow a little bit. And up until now with this amp, we haven't seen that because we haven't had any current running through it. We've just been testing the voltage at the power supply. So this glowing a little bit tells me that we're now conducting some current in here. So let's look over here at the cathodes of these tubes. And sure enough, there's 13 volts. And on the other tube, we got 13 volts. If there wasn't any current being conducted by these output tubes, we wouldn't see any volt on the cathode. So we know that now they're starting to conduct current. So let's go ahead and turn this up to about 100 volts and see what that does to our B+. Okay, there's 285, 286. Now let's see what we have at the plates of the tube. On the other side of the output transformers, we got 281, so just a few volts less, and that's because of the voltage drop from the resistance of the output transformers. We're basically 281. Now we have coming up on 18 volts on that cathode and somewhere on that one. They're both about 17.9-ish. Okay, now let's go ahead and turn this up to what we have marked on our Variac. It's 120 volts. And now you can see this is starting to glow a lot brighter. And that's telling us that we're now drawing more current through the output tubes and the amplifier, which is making this glow because this is basically acting as a current limiter. So now we're going to come over here and see our B+ is now at 330. This plate's at 326, which is a lot less than we were hoping to see. And we got 21 volts on that cathode and 21 volts on that cathode. So these tubes so far look like a really good match to each other. I do want to add that on a single-ended amp, having matched pair of tubes isn't that critical. The only problem that unmatched tubes would cause is that the volume on one channel would be just a little louder than the other. Now with a push-pull amp, they need to be matched because, again, you're doing the matching of the positive and the negatives, and if they're not amplified equally, you're going to get distortion when they're trying to combine back together in the output transformer. So that's the big deal with matched pairs of tubes or matched quads, is used for push-pull amps. So you can save a few bucks by not buying matched pairs for your SE amp. And like I said, the only difference is going to be that one channel might be a dB or more loud than the other channel. So it's not a huge deal. So what we're seeing here is we're not seeing the voltage on the B+ that we were hoping for. But we have the dim bulb in the system. And the dim bulb here is sucking up some of our voltage and limiting how much current is going to the amplifier. So we're going to come over here and connect the alligator clip onto one side of our IEC connector. Switch this to AC, and we're going to check. And yeah, we've got 98 volts going into the amplifier when we're showing 120 here. So, given that we know we don't have a short, this is where we take the dim bulb out of the system. So, let's move this back over to our ground point. Put it back on DC. Then we're going to turn off the power, and we're already down to 8 volts on our B+. That shows you how fast these tubes drawing current plus the bleeder resistor is pulling down the B+ after we turn the power off. So if we had just the rectifier tube and no output tubes, and we're just relying on the bleeder resistor, it would take a lot longer for the voltage to come down. So at this point, like I said, we know we don't have a short, so we can take the dim bulb out of the circuit, plug the amp straight into our isolation transformer. We're going to set this on 100 volts because that's what we've had up until this point. And turn this back on and see what our B+ is. Now with the rectifier tube partially warmed up, the B+ comes up a lot faster. Okay, with the dim bulb out, we've got 350 volts on the B+. We got 21 volts on that cathode and 22 volts on that cathode. Let's go ahead and crank this thing up to 110 volts and see where we're at. As you can see, this hand stayed in my lap the whole time. Keep being one hand Pam or one hand Sam, whichever you are. Okay, our B+ is now 387. And on the plate we have 383. And on the cathode we have 26 volts. Man, we're starting to get somewhere. I'm going to go ahead and turn this up to what should be around 120 volts. Again, this voltage thing does depend on the load that's on the variac. And so, you know, measuring the voltage unloaded versus loaded is going to be different. But this should be 120-ish volts going into the amp. And we have 411 volts at the B+. That's more like what we want to see. There's 406 on that plate. There's 406 on that plate. Got 28.46, which is 28.5 volts. And 28.53 on that one, which 28.5 volts. The next thing I want to do is I want to make sure that we're testing this of what it's going to be like plugged into my wall outlet. And I'm getting around 121 to 122 volts at the wall in my house. So let's go over here to the IAC connector, put this back on AC, and okay, that's 116. So we need to turn this thing up some more. There's 120. Give it a little more. Okay, there's 121.5. That's real close to what my house is, just directly plugged into the wall. And again, don't have your hand over here and then be over here, because if you slip and then like you slip with both hands, which isn't likely, but if you do, you could end up getting the voltage going from this hand across your body into the ground of this thing, And even though it wouldn't be the full 400 and something volts, you don't want to feel what even 65 or 70 volts across this feels like. So keep your hand in your lap. Okay, so we know we have close to right at 120, like 121.5 volts. And we're going to switch back to DC, and let's see what we have now on our B+. Okay, there's 431. Okay, so on the plate of this tube, we got 423. Come over here, got 423. Come over here to the cathodes. We have 30.09, so it's basically 30 volts. And then we got 30.26. Really close to each other. So one more time, I want to come back over here and check my input voltage. We might want to turn it up just a little more to ensure that we're getting a realistic, like what we're going to see at the wall. I'm going to go ahead and bump it up just a breath. And there's 122. Let's come back here, check our voltages one last time, and then we're going to go do some calculations. Oop. Let's put it on DC. 428. There's 426. 426. There's 30.35. And there's 30.69. So it's 30.5. So let's write these numbers down. We've got 426. We got 426 on the plate. And 30.5 on the cathode. Now, we'll go ahead and turn this off. There's a lot of different ways of calculating this stuff. There's math equations that you could go through to try to figure out the watts and the dissipation and the milliamps and all that stuff. I'm going to put a link below of a website that I use that lets you plug in. It's got a whole list of the different tubes, so you can pick your tube. Then you can put in your plate to cathode voltage, which is different than what we just measured here. Don't get confused by that. When they're talking about the maximum in the data sheet, and they're talking about, like in this formula, you measure from the plate to the cathode. So even though we saw 426 volts on the plate to ground, you need to subtract the 30.5 volts to get your actual plate voltage that you put into this formula. And I see people making that mistake where they calculate this up using the plate to ground voltage, and with a cathode biased amp, that's not what the real plate voltage is, because the tube isn't seeing that. It's seeing what's on the other side of the cathode resistor from ground. So if you want to do the long form math, go ahead, but I've got no interest in doing that. I don't have anything to prove to anybody, so I'm fine using these little cheat sheet websites. I do the same thing with my ohms calculator. I'll link that in the description too. There's a cool little site where you can put in two things and it gives you the others. It tells you how many watts of resistor that you need, and it helps avoid mistakes in you doing longhand math. But if you want to do longhand math, go right ahead. So let me go plug these into that website, and I'll be right back and tell you the results. Okay, plug these numbers into my little website sheet, and we came up with, we got 61 milliamperes of current going across the cathode resistor, and it averages what it thinks the current going through the screen would be. And so it comes up with, we have 58 milliamps of current. Then we also have 23 watts of dissipation, maybe 22.6 or something like that. And we're right at 92% of what the maximum dissipation of the tube is. Now guys, that's running this tube pretty hot. But again, these are $17 tubes. I don't mind being a little abusive on them. And I've run these JJ EL34s this hot, and I haven't had a problem yet. So we're going to run these things this hot. I'm really happy with where we're at. And the voltages at this point are right in line with what I was hoping to see. From my experience, that once you get all of these voltages where you want to see them, the driver tubes pull such small amounts of current that they're not going to have really any impact on the B+ or going to change what we're seeing here at these output tubes. The other thing I wanted to mention too, if you've been watching this video up until this point, basically what we have here is the basis of any kind of EL34 single inlet amp that you'd ever want to build. The only thing that would change at this point is what we're using to drive them with. You could use a 12AX7, you could use these two 6SQ7s, you could use some 6SF5s, I think they are, that are the single triodes. There's a whole bunch of different tubes you could use to drive these. So this basic thing that we've done and this basic schematic on the back end could be the basis of any kind of EL34 single inlet amp you'd ever want to build. So at this point, we're doing it with these 6SQ7s, and we can now move on to doing that part of the build. It should go pretty quickly from this point. Yeah, I know I've said that before. It's probably under 10 videos, but we're going to try to zip along here. We've got to hook up the RCA jacks to the volume control, and I'm going to show you my little tricks on doing that to make sure that we don't get any noise, especially with this long a run. And then we need to wire up these triodes that are going to be a lot easier to do than the 300B amp was, because it had that cascode with dual triodes and all that. We just have a single triode. We got power wire going to it. We've got grid signal, and then we got the cathode, which is going to be an LED and a resistor, which makes it even easier to deal with. So hopefully we can zip this thing along and get listening to this amp and see what it sounds like. So I really hope you're enjoying this content and you're enjoying my channel. If you are, please subscribe, please like the video, and we'll be back real soon for more 6SQ7 fun. Have a great day.